Dear students, welcome to B.R. Ambedkar Open University series of lectures under Geography. Today, we will focus on Introduction to Remote Sensing, under which we will discuss about evolution of remote sensing platforms. So, before we proceed with remote sensing platforms, what is remote sensing? Remote sensing is defined as the process of obtaining information about the object without coming in contact with the object. So, this information is gathered by specialized instruments like cameras and sensors. If it is an aeroplane, we have cameras, and with the satellite, we have sensors. So, these cameras and sensors are placed in a special kind of vehicles, and those vehicles we define as remote sensing platforms. So, we define remote sensing platforms as the vehicle that actually carry on board different type of instruments that capture information from a distance of the earth's surface. So, depending upon the altitude, we categorize remote sensing platforms into three types as ground or terrestrial, airborne platforms and spaceborne platforms. So, first we talk about ground or the terrestrial platforms. So, these are the platforms which actually typically carry out with the handheld cameras. It may be with the film or the digital cameras, and with the help of the platforms are the cranes or some kind of ground vehicles, and in some case we use even the towers and the balloons. So, these are the platforms, and in these platforms we have these specialized instruments, that is the sensors or the cameras. So, since these platforms are at the low altitude, there is a possibility of getting a very high resolution imagery, where actually we can clearly see different features that are present on the surface of the earth. So, these platforms, they can be either static, something like a tripod. On the tripod we can have our instruments, something like cameras, or they may be dynamic. In dynamic case, a moving vehicle. So, in the moving vehicle we can have these kind of instruments. So, either the static or the dynamic will try to collect the information using these instruments, specialized instruments. So, these platforms are also classified as a short range, medium and the long ranges. Short ranges are typically from 50 to 100 meters, medium up to 250 meters and long up to the 1000 meters respectively. So, what is the advantage of this short, medium and long ranges is, short ranges, which is something from 50 to 100 meters, helps us in carrying the information about the very detailed information about the buildings and the other structures, while the medium range help us in modeling the 3D modeling of the features, and the long range, which is up to 1000 meters, will help us in getting the information about the topography of the area. So, the data collected by these platforms are useful for various applications. Typically, since they are at the low altitude, they provide a very high resolution data sets. So, they typically help us in monitoring the infrastructure constructions like bridges and dams monitoring, and in some cases we also monitor landslides or any other soil erosion mapping or the architectural restoration facilities. So, we have multiple applications using these ground or terrestrial platforms. Next, we have airborne. Airborne, actually the platforms which are actually moving in the atmosphere. So, typically these vehicles, they operate in the atmosphere. So, on these vehicles include aeroplanes or the helicopters, and even in some cases we also use the rockets, which are actually ascending up to almost 600 to 2600 meters height. So, these airborne are also at the little low altitude compared to that of the ground terrestrial, and they also provide us a very good high resolution data sets. So typically if it is an aeroplane, we have the camera, and this camera captures the information, and what the image what we got is the aerial photography, and this is used for different purpose, especially for the surveying and the mapping purpose. We can categorize these airborne platforms into two as manned and unmanned. In the manned aircraft, actually there is a pilot or a human who actually controls over these platforms, and the instruments are attached either to the belly of the platform, something like aeroplane, or sometimes the pilot or the human operator carries the cameras. So it was something a primitive method where actually a human carry the cameras in the aircraft, and they used to take the picture, and now we also have these cameras attached to the belly of the aeroplane that actually captures the information, and that information is the aerial photograph. So these instruments are capable of surveying large areas and provide very good detailed information that help us in doing different mapping processes. And we have the second category, unmanned aerial vehicles. Unmanned aerial vehicles are nothing but we define what we call as a drones. So these are also fly at the very low altitude, and they provide very good high resolution data sets. So these unmanned vehicles are mostly useful where actually there is a accessibility is a problem. Suppose if you want to do some kind of mapping for the high canopy or the tree canopy areas which is actually not accessible, so we using the drones which have the cameras, we can capture the information. And currently these drones which are equipped with the cameras, multispectral cameras, they also useful in the infrastructure monitoring, such as monitoring of the dams and the bridges. So mostly it is manually it is something difficult to track the cracks, something problem within the infrastructure of that very high dams. So using drones where actually which will fly to the height of the dams, captures the information about such health of the infrastructure, and that can be monitored. Apart from this, drones are currently useful in multiple areas like in the forestry, agriculture, and in different domains, where actually they provide us both the RGB, that is the visible images, also the multispectral which are operating in the infrared and also in the thermal infrared bands. So drones ultimately provide a very high resolution data sets. Now coming to the space-borne platforms, the name itself indicates that these are the platforms what actually we see in the space. So these space-borne platforms, it can be mostly the satellites, and in some cases sometimes we also make use of the space transport system, what we call as a space shuttle also as one of the platform. So these satellites are equipped with special type of sensors that actually capture the information as these satellites move over the Earth surface in the different orbits. So satellite based remote sensing we also call as an orbital remote sensing process, as they are moving in the different orbits. So it can be basically we classify these orbits into high Earth orbits, medium Earth orbits, and low Earth orbits. So satellites are placed in any of these orbits. If it is an high Earth orbit, mostly these satellites placed in this orbit are typically called as a geostationary satellites at the height of 36,000 kilometers, and typically helps in monitoring the weather and the other parameters. So mostly weather satellites are placed in this high Earth orbits. Then we have medium Earth orbits. The satellites in this medium Earth orbit are typically placed at an height of 20,200 kilometers, and the satellites in this are typically helps in the process of navigation. So whatever the GPS we see, the satellites in the GPS which are capturing the GPS information are mostly placed in this medium Earth orbit. Then we have low Earth orbit, which are very close to the surface of the Earth, ranging between 500 to 700 kilometers, and typically they capture very high resolution. So, mostly polar or the near polar orbit satellites are found in these low Earth orbits, providing very high resolutions. So, spaceborne platforms, they can be remain for the short duration in the space, something like a space shuttle, which is for maybe for 1 or 2 weeks, or some other satellites which are for the longer duration. So, most of the satellites what we see in the space are for the longer duration. Typically, we have this Landsat series of satellites, and we also have the Indian remote sensing satellites, which are actually placed in the orbit with a defined time of working process. So, they may be from some 5 to 6 years, later on they actually move out of the orbit, but first they remain for longer time within the space and continuously move within the orbits and capture the information. So, these satellites which are actually operating in the low Earth orbit or even in the high Earth orbit or in the medium Earth orbit, but medium Earth orbit are actually helpful in the navigation process for the GPS thing, while high Earth orbit satellites, which are the geostationary satellites, and the low Earth orbit satellites, which are the polar satellites, they typically capture the information about the different parts of the globe, and this information is not a single time, it captures the dynamic information that typically helps us in monitoring the different features on the surface of the Earth. If it is a geostationary satellites, they actually help us in monitoring the weather pattern, flooding scenarios and the cyclone scenarios. If it is a polar satellites, they help us in monitoring the what is the change in the forest, what is the change in the water quality and water extent. So, different natural resources can be monitored using these satellites. So, overall we can see these are the ground or the terrestrial platforms where the camera is placed on a tripod, or there is some kind of a crane that actually carries the human, which has a handheld camera that takes the picture. So, it is mostly operating at the low altitude. Then we have the airborne platforms like aircraft, helicopters sometimes. Even balloons were used once long back as one of the platforms, and we have the tethered balloon as well as airship. So, currently out of this mostly we see aeroplane as one of the primitive and the best platform that actually captures the information using the cameras, and it is one of the significant airborne platforms. Then coming to the spaceborne, we have these different satellites which are operating in the space at different orbits capturing the information, and we also has the space shuttle. So, if you look into the how these platforms have evolved, currently what we see is the satellites and under drones. So, these are the two current instruments that typically helps us capturing information about the Earth's surface. But if you look into how this evolution happened, then there is an evolution from aerial photograph from balloons to the satellites. If it is a balloon which actually carries the camera, we have the aerial photograph, and if it is a satellite, then we have the satellite imagery. So, now we look into how the process of evolution happened with relation to platforms, and how gradually we can see there is an evolution of platform from starting to the satellite, and what are the different platforms are actually used primitively before the starting of the remote sensing. So, if you look into the remote sensing phenomena and the evolution of the platforms, photography is something one of the greatest invention which actually triggered this kind of remote sensing phenomena. So, primitively cameras are the remote sensors which are still also useful as one of the best sensors that captures the information. Camera remained as one of the best instrument in capturing the information about the objects for more than greater than 150 years, and also still we use this kind of aerial photographs that is derived from the cameras as one of the major input for the monitoring different features on the surface of the earth. So this is the first photograph which was captured in 1827 using the camera, where actually that is the starting of the photographing. Then in 1839 this is a aerial photograph which actually took from a kind of a tall surface, maybe a building, and this actually what we call as a typical proximal remote sensing. Then the idea of capturing the information or the photograph from the certain height, it is actually what we call as a aerial photograph, was started around 1860, where balloons were used as one of the platforms. So balloons actually anchor with one kind of a platform that actually carries the human beings, and the human beings actually they have the camera, and when the balloon ascends up, they used to take the picture of the particular area. So this idea of taking the pictures using the cameras and the balloon was started first by the Nadar. So this is one of the primitive photograph which is actually taken from a balloon as a platform around 1868, and this is the first surviving aerial photo of the world. There is one more picture of the Boston James Wallace around taken up at a height of 1200 feet around 1860. So balloons are thought to be the first platforms that actually resulted in the creation of the aerial photographs. Then the curious of taking pictures, aerial photography was started, where actually kites were used as one of the platforms to capture the images, where we call this as a kite aerial photography. Kite aerial photography was the first thought by Arthur Butwood, who actually attached a camera to the kite, and when the kite is actually ascended up, there is a burning fusing mechanism that actually opens the shutter of the camera and takes the picture. Once the picture is done, it actually releases a small flag indicating that it has taken the picture. So then once that sign is there, they used to bring down the kite to the ground. So this is the first process, and this is a photograph of the kite aerial photograph of the Labrador fans around 1889. One of the adventure invention by Arthur Butwood using the kite. Then continuing the journey around 1906, George Lawrence also took pictures of the San Francisco after the great major earthquake using the kite aerial photography. But the process of taking pictures by John Lawrence is something different from that of the Arthur Butwood, where actually Lawrence, instead of a single kite, he used a canoe, a series of kites of 9 to 17 large kites, which actually can hold the camera of around 49 pounds size, and they ascend the kite to a height of 2000 feet. So when the kite ascended up, actually from the bottom actually there is a piano wire that is connected to the camera, which actually supplies the electricity, and the camera is supported with a tripod, a bamboo like structure that makes the stabilized the camera. Once the camera reaches the height, a certain height, it actually takes the picture, and once the picture is done, it releases a small parachute indicating that it has taken the picture and it is a time to move it down. So this is the tripod that is supporting the camera, and these are the series of canoes of the kites. So the main purpose of having a series of kites is to make the camera stable so that there should not be any distortion. So using this kind of a series of 9 to 7 large kites, he created this kind of new kite aerial photography, and what he called it as a captive airship. So using this, when there was a earthquake in the San Francisco, John Lawrence took picture of this area, and this picture actually fascinated military people, military people, and then he sold this for around $15,000, and it is one of the best photograph taken from the kites. So during the World War time also, army they used kites as one of the mechanism to identify the trenches by taking the camera pictures of their enemy trenches. If you look into the further kite aerial photography, the major contribution comes from the Samuel Franklin Cody. Cody actually he come up with an idea of carrying human beings along with the kite. So, the previous if you look into Arthur Batut and the Lawrence, they just have the camera with the kite, but Cody idea is to design a kite that actually can carry the people into the up while ascending the kite to the heights. So, he started experimenting and then his experiment was successful. Later on in 1903, actually he come up with 1901 he come up with a kind of a Hargrave box kite with the extended wings. So, with extended wings that actually carries the people. So, this invention was actually attracted the people. Then later on he started his experiments where actually it tried to slowly increase or ascend the kite to certain heights that actually carrying the people. So, this experiment was shown initially by one of his son who ascended up to 200 feet. Then Cody himself ascended up to 400 feet, and then his one more son actually ascended up to 800 feet. So, during this process of transition from 200, 400, 800 reaching to the certain height, the final height that is achieved by this Cody team is around 2600 feet. So, then later on as a continuation of his experiments, Cody actually designed a float airplane, and while testing this in 1913, he along with one more his co-passenger actually fell from a height of 200 feet and killed in the incident. So, this could not be a successful invention. However, Cody's contribution related to this kind of kite aerial photography is something noteworthy. These are the different pictures taken from the kite aerial photography. So, kite aerial photography actually gained importance. So, with the invention of the microelectronics, digital cameras and the internet, it is actually made easy to have a cameras that can actually carried by the kite, where actually they can take the photographs. Kite aerial photography is typically useful in areas like monitoring bird species and assessing different kinds of geological and the mineral resources. However, it is not practically commercially good because of the bad weather conditions, especially when the kites are actually flown near to the buildings or under the trees. Actually, there is a more turbulence. So, but kite aerial photography is something beneficial compared to that of the unmanned aerial vehicles, the small drones. Actually, drones need some kind of permissions and some access areas it is not possible. So, in those areas we can make use of the kite aerial photography. So, people still continue with this kite aerial photography in some areas, and this is one of the kite aerial photography taken and is one of the best photograph. It won in the competition. Following this kite aerial photography, then we have the pigeon aerial photography, which is something one of the important invention in the process of evolution of the remote sensing platforms. So, in the pigeon aerial photography, there is a camera that is attached to the breast of the birds, the pigeons. It has a mechanism that at every 30 seconds it actually takes the photograph. So, this invention actually come up by the idea of Julius Nebronen. Julius Nebronen, who is actually son of apothecary, in a simple term is a pharmacist, who actually prepares the medicines based upon the prescriptions that is given by the doctors. So, Julius Nebronen's father actually has a home pigeons which actually bring the prescriptions from the nearby doctors. So, during this process, once one of the pigeon was not returned for almost a month time. So, Julius Nebronen was curious that what happened to this bird, why there is a delay for this bird coming back to the home after 30 days. So, this curious actually made him to attach a kind of a camera to the breast of the bird and actually captures the pictures when the pigeon is flying at the different locations, and that is how the idea of pigeon aerial photography gained importance, where actually people started taking the pictures so using the pigeon aerial photography. So this is the picture of Skolostotel Kronberg around 1889 near Frankfurt, Germany. And here you can see when the bird is taking the picture, we can also see the wings of the bird. Pigeon aerial photography gained importance even during the World War time, where actually these pigeons are also used to gather information about the enemies. So it acts as a spy. So this totally revolutionized the field of aerial photography. Then these are the pictures taken by Julius Nebronen pigeon, that is actually in 1909, and which is actually presented in the International Photographic Exhibition. Then we have aircraft. So when you talk about the evolution of the platforms, we also take the contributions of the Kodak, Eastman, actually who come up with the Kodak cameras. So because cameras and the platforms are parallelly evolved, and the development of the Kodak camera by Eastman, at the same time Wilbur brothers actually they come up with this idea of aircraft. So both the aircraft with the camera as served as one of the best platform for taking the aerial photography. So using the cameras, Wilbur Wright, one of the brother of the Wright brothers, he took pictures of Italy and France in 1908 and 1909, and this aerial photography gained much importance during the World War time also, where actually the countries they had started taking pictures of the enemy trenches. So the camera can be attached to the side of the flight, or it can be attached to the bottom of the belly of the camera aircraft, or sometimes handheld by the people who take the pictures. So this is the Wilbur Wright first aerial photograph of the France. Then we have the rockets. So the first photo was taken at the height of 100 meters, and this is designed by Alfred Nobel. Then in the experiment he ascended up to 600 meters finally, and where actually the rocket which has the camera that took the picture. Then Goddard actually he come up with the successfully first rocket with using the liquid fuel, but actually you can see Goddard with his rocket having the barometer and the camera, and this rocket when ascended up it took the picture. So there are different types of rockets that are experimented by the people launched into the space to capture the information, where actually to the nose of the rocket they attach the camera, and camera while ascending up it took the picture. So there are different small sounding rockets, or the experiment rockets are also experimented. They try to reach to the suborbital level, not totally into the space, but only up to the suborbital level. We can see there is an evolution of the different rockets. Then we have satellites. So the modern space program started with the launching of the orbit the Sputnik by the Soviet Union. Actually you can see the model of the Sputnik with the scientific instrument, and this is a semi-Yorker rocket that actually carried this Sputnik into the space. Then NASA also started, the US also into the race of the competition of launching different vehicles into the space, where actually when they are planning, Sputnik actually gave the sudden impetus, and finally Russians are successful in sending this rocket into the space when compared to that of the NASA. NASA they first experimented one orbiting satellite which is called as an Explorer, that actually captures the information about the radiation around the Earth's surface. The satellite looks more like a probe, actually with a length of 203 centimeters long, and it has a weight of 66 kilograms. So the point close to the Earth is the 363 kilometers, and the apogee is the farthest point is the 2552 kilometers. That is, if there is a Earth and around the Earth this satellite is moving, so the which is closest distance is the perigee and the farthest distance is the apogee. Then on July 29, 1958, they started this National Aeronautic and Space Agency, where NASA was informed, and in 1960 the term officially remote sensing was coined. So NASA they actually has a different series of Landsat satellites starting from 1, 2, 3, 4, 5. 6th mission was failed, and again 7, 8, 9. So currently we have the 9th series of the Landsat satellites. So then while people are actually either USA or Russia, they started sending rockets into the space. Russians are very curious that is it possible to send living creatures into the space, where actually they first tried with sending dog Laika into the space without returning them. Later on, people they also enter into the space, like we have Yuri Gagarin, Alan Shepard, who finally landed on the moon to capture the information about the moon's atmosphere. Then we have the Indian remote sensing satellites launched by the ISRO, that is the Indian Space Research Organization. So after successful launching of the Bhaskara 1 and Bhaskara 2, they started coming with the different missions of the satellites. Initially, the satellites are named as INSAT 1A, 1B, 1C, 1D. Later on, they started naming the satellites based upon their applications, like Cartosat for the large scale mapping, ResourceSat for the natural resource mapping, OceanSat for the ocean surface, etc. And finally, they have a name also on the based upon the platforms. If it is a polar satellite, they call it as a PSLV. If it is a geostationary satellites, they are calling it as a GSLV satellite launching vehicles.